So now let's look at some more implicit differentiation problems. Let's look at the following problem. Let's determine the slope of the tangent line to the graph of x squared plus 4y squared equals 4 at the point square root of 2, negative 1 over the square root of 2. So we're going to follow our same procedure steps to get the derivative that we did in the last video. So take your equation and then take the derivative of both sides. That's step 1. So if I take the derivative here, I'm getting 2x plus 8y dy dx equals 0. Now I need to get all my dy dx terms on one side. So I'm going to leave this one over here, and I'm going to move this one to the other side over here. So subtract 2x. So you'll get 8y dy dx equals negative 2x. And then to solve for dy dx, you just divide by 8y, and you'll get that the derivative is negative x over 4y. Now I was asked for the slope of the tangent line at the point square root of 2, negative 1 over square root of 2. So to get the slope of our tangent line, I'm going to plug in this point, this for x, this is x, and this is y, into our derivative over here to get the slope. So the slope, m, of our tangent line, it would be negative square root of 2 over 4, negative 1 over the square root of 2. So if you flip that bottom fraction up, you'll get negative square root of 2 there. So it'll become a positive 2 over 4, or 1/2. And there is the slope of my tangent line. All right, let's look at one more. The following example. Determine the slope of the graph 3x squared plus y squared squared equals 100 times xy at the point 3, 1. So again, going back to our implicit differentiation procedures, take the derivative of both sides of the equation. So for this one on the left, you're going to have to use the chain rule here when you take this derivative. It has an inside and an outside. So the first thing you're going to do is the power rule. Bring the 2 down. That reduces the power to 1. And then you've got to multiply by the derivative of the inside. And then here, I can factor out the 100 because it's just a constant. And then I'm doing the product rule here. So x times the derivative of y, dy dx, plus y times the derivative of x, which is just 1. So if we, let's see, we get 6x squared plus y squared, and then you'll get 2x plus 2y dy dx equals 100x dy dx plus 100y. So I'm going to distribute here on the left. So I'll get 12x x squared plus y squared plus 12y x squared plus y squared dy dx equals 100x dy dx plus 100y. So I'm done taking the derivative. And remember, we need to isolate our dy dx terms on one side of the equation. So, So I'm going to move all of them over here to the left. And then any term that doesn't have a dy dx will have to go to this other side here. So I'm getting 12y x squared plus y squared dy dx minus 100x dy dx equals 100y minus 12x x squared plus y squared. And then factor out our dy dx. You get 12y x squared plus y squared minus 100x equals 100y minus 12x x squared plus y squared. And then to solve, I just need to divide by that thing in the brackets. So 100y minus 12x x squared plus y squared over 12y x squared plus y squared minus 100x. If you want, if you notice, all the coefficients are multiples of 4, so you could factor a 4 out of the top and bottom and cancel it out. 25y minus 3x x squared plus y squared over 3y x squared plus y squared minus 25x. And then remember, we're interested at the point 3, 1. So here is my x value, here's my y value, and you're going to plug it into your derivative now to get the slope of your graph. Dy dx 25 minus 3 times 3 squared plus 1 squared divided by 3 squared plus 1 squared minus 25 times 3, 25 minus 90 over 30 minus 75, and if you simplify that ratio down, you'll get 13 over 9. There's the slope of my graph at the point 3, 1.